In this video, we're going to go over osmosis. So osmosis is the diffusion of water across a selectively permeable membrane when there is a concentration gradient and the water diffuses from the solution with the lower solute concentration to the solution with the higher solute concentration until both solution concentrations are the same. So you can see here we have two pictures. We have seawater and freshwater before and after osmosis, and they're separated by a semi-permeable membrane. Water from the freshwater side diffuses across the membrane to the seawater side through osmosis. As a result, the volume of seawater increases and the volume of freshwater decreases, and the concentration equalize. The water from the freshwater side goes to the seawater side because the seawater is more concentrated or has more solutes in it than the freshwater. So it's trying to balance it out. The direction in which water diffuses is governed by the total number of solute particles in the solution or the molar concentration, not by their mass or identity. Osmolarity is the molar concentration of all the particles in solution that contribute to osmotic pressure. So a solution containing 2 millimolar glucose and 3 millimolar urea has a total osmolarity of 5 millimolar. Osmotic pressure is the amount of external pressure applied to the more concentrated solution to prevent osmosis. Reverse osmosis is pressure greater than the osmotic pressure, causing water to flow against the concentration gradient. So osmosis is what happens naturally. Reverse osmosis is adding pressure to have things go against the concentration gradient. So when we apply pressure in reverse osmosis, we have salt water and fresh water. Salt water has more solutes in it, but with applied pressure, we will have the water flowing towards the fresh water instead, causing the freshwater volume to increase, even though the freshwater had less solutes in it. In areas where fresh water is scarce, reverse osmosis is used to produce drinking water from seawater. So we have pressure, we get salt water, you do reverse osmosis on the salt water, and then you get fresh water out of it. You just get the water molecules instead of the salt molecules. You're increasing your volume of fresh water. Reverse osmosis is used to force excess water out of the blood as it's being filtered during hemodialysis, a life support treatment for individuals with kidney disease. So those are two applications of reverse osmosis. Tonicity, these are terms used when comparing the concentration of two solutions separated by a semi-permeable membrane. So the hypertonic solution is the more concentrated solution. The hypotonic solution is the more dilute solution, so has less solutes. And an isotonic solution are solutions with equal concentration. And the tonicity of solution are used to predict the direction of osmosis. Remember, so using these definitions, osmosis is defined as the diffusion of water from the hypotonic solution to the hypertonic solution until both solutions are isotonic. So osmosis in red blood cells, we can see here that when red blood cells are placed in an isotonic solution, they maintain their healthy biconcave shape. We have our cell membrane, which is a semi-permeable membrane. Our extracellular solution and our intracellular solution have the same number of solutes. They are isotonic with each other. They have the same concentration. IV fluids always give solutions that are isotonic with red blood cells. Physiological saline solution is isotonic with red blood cells. When red blood cells are immersed in the hypotonic solution, so the hypotonic solution has less solutes than the solutes in the red blood cell itself. Water diffuses through the membrane into the red blood cell through osmosis, The volume of the red blood cell increases and it swells until it eventually bursts. And that's called hemolysis, is when it bursts. If red blood cells are put in a hypertonic solution where the solution around it has more solutes than what's in the red blood cell, then the water within the cell is going to go to the hypertonic solution and diffuse the cell membrane. The volume of the red blood cell decreases because the water is leaving it, and this is known as crenation. Both hemolysis and crenation can lead to the deformation and the lysis of red blood cells. So in summary, osmosis is the diffusion of water across a selectively permeable membrane from the less concentrated solution to the more concentrated solution. The volume of the more concentrated solution increases as a result. Osmotic pressure is the external pressure that must be applied to a more concentrated solution to prevent osmosis. And reverse osmosis occurs when an external pressure greater than the osmotic pressure is applied, causing water to diffuse against the concentration gradient. IV solutions must be isotonic with red blood cells to maintain the normal volume of the cell. In a hypotonic solution, water enters the cell, causing hemolysis. In a hypertonic solution, water diffuses out of the cell, causing crenation.